Hello, in this section we're going to be looking at how to graph an exponential function. To graph an exponential function, we'll need to know the basic shape of the function, we'll need to plot 3 points, and we'll need to know where that asymptote goes. So, to graph y equals b to the x, where b is greater than 0 and b does not equal 1. And again, that's the definition of an exponential function. If we're graphing something of this form, then the y-intercept will be at 0, 1. Always. Doesn't matter what the base is, the y-intercept is at 0, 1. Furthermore, we will also have the points 1b and -1 b inverse. I like to use those points. You can use other points, but those are really the easiest ones to use. They'll have the smallest numbers. Finally, the x-axis is an asymptote. And that, right there, will be enough information to graph an exponential function. So let's look at 3 quick examples. The first one is f of x equals 3 to the x. 3 to the x. So what we're going to do, just quickly draw some axes. Again, take your time when you draw your axes. Remember, it's important to label the scale. I'm counting by ones here. It's also important to label the axes. I labeled those as x and y. It's important to include your arrowheads to show that this graph continues and these axes continue. 3 to the x then has its y-intercept right here at 0, 1. We also here have the point 1, 3 because b is 3. And we have the point -1, 1/3. So if I subdivide that down, there's 1/3. And since the x-axis is an asymptote, you can see that graph right there. Now, it's not an asymptote on the right side. It's growing very quickly. It's growing exponentially, but that's not an asymptotic behavior there. But this is over here as it gets closer and closer to the x-axis, but has no x-intercepts. Similarly, if we were to graph g of x equals 1/2 to the x, this would be graphed the exact same way, but it's going to have a very different look to it. Again, I'm going to go ahead and count by ones. So the x-intercept still at 0, 1, right there. And then we have the point 1b. b is a half now, so a half will be right here. And then -1 b inverse, the reciprocal of b is 2. The reciprocal of 1/2 is 2, so we have -1, 2. That x-axis still is an asymptote, and so that comes down like this, and here's our graph. It looks just like the shape of the other graph, only it's facing the other direction. Finally, let's graph one of these that's been shifted around. If we had h of x equals 2 to the x plus 1 minus 3, then each of these things is really directions. So it's important for us then to recognize that what the -3 tells us is to shift down, and what the +1 tells us is to shift left. Just to keep that in mind, let's go ahead and label this. There's 0, 1. There's 0, 1. Here's 1b, which is 1, 1/2. There is -1b, which is -1, 2. There is 1b, which is 1, 3. And here is negative 1, b inverse, which is negative 1, 1/3. So this time, as I draw my axes, and I think I have room for that right here. As I draw my axes this time, the first thing I notice is that we have shifted down 3. By shifting down 3, we have shifted that asymptote off of the x-axis so that it's now down at negative 3. Because we've done that, we now have to draw the asymptote. It'll be drawn as a dashed line, and it has arrowheads because it continues forever as well. And so we draw that asymptote down here. Next, the point 0, 1 is no longer at 0, 1. The point 0, 1 is now down at this point here. Because, oops, no it's not. It's actually at this point here because we're also shifting left 1. So there's our new 0, 1 that's been shifted to the left. 1, 2 would be at 1, 2. There's our version of 1, 2. And over here we have negative 1, 1/2, which will be right there. And draw that graph. This graph does have an x-intercept, as it turns out, but it doesn't cross that asymptote. So again, just labeling those points as I have named them. This is our version of 0, 1. Is it really 0, 1? No, of course not. It looks like it's negative 1, negative 2, but that's our version of 0, 1. Over here is our version of 1b, which became 1, 2. And again, it's not really 1, 2, but it's close to that. And finally, off here to the left is our version of negative 1, 1 b inverse, which is negative 1, 1/2. Again, I've put quotation marks around each of these point labels because those aren't really what they are, and it's not something you would typically write down. But if I were to look at a graph, I would like to see these 3 points. I want to see the points that you drew your curve through, 3 points that you drew your curve through, and I want to see that asymptote. If it's not on the x-axis, then you need to go ahead and draw that asymptote. But that's all it takes to draw an exponential function.